Welcome to assignment 3 or lesson 3 or actually project 3 in the Arduino starter kit that we're working on for electronics. Today we're working on something called the Love-O-Meter. Kind of similar to one of those things that maybe at a carnival you'd hit and see how high you get, or something where you touch it to see how hot your body temperature is, to see how suave you are or something like that. I don't know what the word I'm looking for is. Irresistible, where it checks your body heat and the Love-O-Meter goes up or it goes down. And fun thing here, you can actually write the code after once you get comfortable at the end of this project. You could tweak it so that like your friends will never be able to light all the lights up, so they're never as hot as you if you change the code. Probably like a carnival trick, actually. I might be revealing insider secrets there, because carnivals aren't rigged. Anyway, we are going to do some stuff today. We're going to create a Love-O-Meter. It's going to look something like this in the end. First thing, there's a bit of an error in this book. Not necessarily an error. It's more of a case-by-case problem, but I found a solution for it. And I'll explain that because it's like so many things. When there's a problem, the solution becomes very interesting if you can figure out why. So we're going to go over the things you need to do today. Here we are. So you first of all need to read the project. So right here, you need to read the entire Love-O-Meter project and read about the parts you're going to be using, read about the wiring, read about what the code is going to be and what the code looks like. Just read. This is complicated stuff, right? We're going to do a little reading here and here. Now, I'm going to warn you. From this project on, to varying degrees, things get a lot more intense. With that being said, you can build the board, upload the code, learn the definitions, and do well in this course. You can pass this course, you can do very good. You can make all your projects work. But there is some things in this code and the next couple codes that really, if you want to become a coder, if you want to become interested in building circuits, if you want to take it to a next level for more of a personal enjoyment, or you want a real deep understanding of what you're doing on a higher level, you need to really get these concepts here. You can, some of the stuff here, even for me, is a bit confusing, especially when I only do it once in a while, every semester here or there, every year here or there. I have to brush up on it too. But it gets a lot more complicated. You can still write the code, fix it, build the board, upload the project, get a good grade. So don't be too stressed out if this isn't a passion of yours or it's not something you might want to take to the next level or do personally. That's okay. But if you do, this is the fundamentals of the advanced areas of what you can start to do with an Arduino. So it gets a little bit tricky here. So first of all, read the project, and you've got to focus on else if, A0, which is analog in 0, the for function, and the TMP36 sensor, which is the temperature sensor in your project. And it's a pretty cool sensor. The next thing you'll do is you will, and I put submit where you need to do your stuff on Google Classroom, but you will build the board and follow the flow and the pins. If you want a video, I actually have 2 videos that you need to watch. If you want to watch one while you're building the board, I would suggest you watch this one that I put, which is just a British fella kind of doing it, and he's building the project from the ground up kind of with you. You can definitely follow him if you want to follow along step by step with your booklet as you kind of go with a person who's building it. You can watch his video and pause it and build it with him. You might like that. There's a couple differences, but you can kind of follow along. He's good. So you can actually watch one of those videos while you build the board and take a picture of it, right? Take a picture of your board even before you've uploaded code, because you get marks for that. For wiring it cleanly and properly, you get marks. So take a picture of that. That's the first thing you'll take a picture of. Don't submit it in segments. Submit it all at the end. The next thing is, now, before you get to this code part and verify, watch the video with our Russian friend here. I don't know if he's Russian, but he's got a great accent, and this will be included in the classroom too. There's 2 different versions of him. This is the guy I watch when I need to catch up and brush up on my coding and what the different commands mean and what the different components do. I watch this guy because he's great. He's very clear. I have to even pause and go back a couple times now and then to watch him, but he's going to do a better explanation of telling you what certain aspects of code and what certain pieces of the hardware do even better than I am going to, right? This guy does this. He's a pro. I'm a hobbyist who I kind of volunteered to teach a course like this because I have an interest in it. I watch this. You need to watch this before you ever write the code. Watch this guy. Take your time. We are in no rush here, folks. We've got a whole semester to do these projects. Don't worry. Watch him, pause it, go back, kind of follow along with the code, follow along with what he tells you, and then attempt the code because you will know what it means more. You'll have already read the code, which will be a little confusing. Then you'll wire the board, and then you'll watch this guy, and then you'll actually have a clue kind of what you're doing when you're writing your code. So that's the next step. I'm not saying don't skip this. This isn't optional. I'll just write it. I'll do that. Boom, boom. No. Watch this. You have time. No one's putting any pressure on you to rush through this course. If you say, I have nothing to do, it's because you're not actually doing everything I'm asking of you. So the next step is write the code and verify. And it's a tough code. Take a picture of your verified code. That is worth marks as well. Next up, upload the code to the board, and you will get an error. Fix it, and I'll tell you how to fix it at the end of this lesson, and then submit a picture, maybe a couple pictures of the lights turning on and off. So let's just look at what the level-o-meter does if you have it working, right? So right now, here's my level-o-meter, and you can see there's a light on already. This is the error version. I haven't performed the fix yet. But as you touch it, it gets warmer and it heats up. And as it cools down, it will kind of drop off. And this is one of the problems, is that it doesn't really cool off properly. And when you heat it up, it just heats the whole thing up very quickly. Now, the first thing you could check is make sure your ground wires are nice and clean, because if you do any problems with your ground wires, that'll cause a problem, but there's a better solution to that altogether to make it so it doesn't do this, right? I shut it off, I turn it on, what does it do? That's not what we want. We don't want it just turning on instantly. That's not the level-o-meter, right? Oh, I'm hot, boom! No, that's not how this is supposed to work. So I'll show you with visual evidence why there is a little bit of a problem, and how you could fix it very easily. And one fun thing to tell you is that you could change the code after to change the temperature. You might not know what I'm talking about right now, but you can change the baseline temperature, and you can change every if-else increment to make it harder and harder to sense. So I'll get that out of the way. So let's just look at the project. So once again, read it, focus on these terms, build the board, watch the video with that guy building it if you want, then watch the extra vid, write the code and verify, submit that, upload the code, get the error, we're going to fix it, and you're going to submit it. So submit. Let's look at the project quickly. The level-o-meter, I've kind of talked about this. The first thing, this TMP36, what this sensor does, this little half-moon sensor, and by God, listen to me. Do not put that sensor in with the half facing that way. The half cut off faces that way. Look how I've got this pin. All I'm going to say is that can get very hot, and you can burn your finger if you reverse that. Don't say you haven't been warned. There's no reason you should put that here. So you can see this side is flat on the sensor, and this side is rounded. Follow my instructions, follow the diagram. You'll be fine. If not, it might be very hot. You might need tweezers to take it out, or you could do some serious damage, which you will be responsible for, because I have warned you. Now, the first thing you'll notice here is this sensor takes power, and the power goes in here, and then it goes out here, and we're sending it to A0. There is another problem. Boy, oh boy. How many times have I had people in their first line of code here put a letter O? That's a 0. So there's a problem right there. That could be like, you could try and verify your code 100 times and it won't work. So make sure you write that properly. That's a 0. There's your first clue. And if you put an O anywhere else in the code, you're going to get errors. It's always got to be a 0. Now, this code, this temperature sensor goes in, out to the analog input. Now, what does that mean? Well, this sensor is cool because as it senses heat, it lets more and more voltage go through it. That is fascinating, right? So if it's just got a little bit of heat, just a little bit of voltage passes through. There's a baseline voltage that always is going, and then a little bit more as it gets warmer and warmer and warmer and warmer. So we can write code to read that increase in voltage and make the increase in these lights if you've reached one temperature, another temperature, another temperature. We're going to have to create that volts to a temperature, which we'll do in the code. But you've got to understand that this A0 is called an analog input. And our Russian friend in the video there, he does a great job explaining how this will turn an amount of voltage. Because what's the problem? If we use these digital pins, that's not going to work. We can't use the digital pins. We've got to use something new called the analog inputs. Because a digital pin, what are the two readings a digital pin can make? Low, high, off, on. That's not going to work to build things up in increments. We need something that can gradually change and be read. And that's what these analog inputs are great for. They can read floating kind of variables of voltage coming in and out and change what is getting output because of that. These digital pins can't do that. They say on, off. And that's good for most things, lots of things. They're great. But sometimes you need to use those analog pins when you want things that are changing, right? So you got to be able to use analog pins. That's what these are for. And obviously the microprocessor here and the chips and stuff can regulate that. You know, you got your little CPU there. Now, what's next? So you got to understand that. And then this runs to ground. The third pin of that runs to ground. And that's actually where the problem is. We'll explain that in a bit. This part here, we're going to look at that right away. How you can read this temperature sensor constantly. On our program, it's actually easier, which is pretty cool. So we'll do that right away. You wire the board, you do the reading. Now these are some cool things you need to do. Sensor pin A0, that means you're assigning one of the analog in pins, because that's a new pin. Like I said, it can read different amounts of voltage. And you can set a baseline temperature. Our friend in the video will explain this much better before you code. Now this for command, for pins 2 to pin 5 basically, which is what you're using here, right? 2, 3, 4, right? So pins 2 and 5 under 5, so 2, 3, and 4. What that for command means is if you have to write the same piece of code for each pin, instead of writing out this section right here 3 times, you just say for all 3 of these pins, this is the code. That's what a for command does. So that's another thing. A for command in the definition, which might be on a test, a for command is something that assigns a set of code for all the pins that you've included in it. So all the digital pins that you've included use the same base code to begin with. So there's another thing, right? It said focus on if-else A0, which we've talked about, the analog input. The for command, we've talked about the sensor. And the else-if is just another extension of that if-else. And our friend in the video explains the else-if function much better. So we can look at the code. We can look here, right? Here is our if the temperature is the baseline temperature plus 2, nothing comes on, right? But if it's plus 4, 1 comes on. If it's plus 6, it comes on. I believe that's, there we go, yes. Now, else if means if this happens, great, but if something changes beyond this command, go to the next one. And it says do that unless this one happened. Do this one unless this one happened. And this would be the final step if it was so hot that all the lights turned on. So an else if like bumps it to the next level of code. If, do this, or else if it's not this, do the next thing. Do this thing, else if that thing is met, then do that thing. do this thing, else if that thing's met. It's kind of bumping the code forward. That's how you get these lights to light up more and more and more as the thing gets warmer and warmer and warmer. And the temperature reading that we sent to this A0 and then sent out through these 3 pins as it gets hotter, turn on the lights. Pretty cool. I'm trying to explain it a little bit quick, but I can help you in the class or if you have some questions. And I'm going to tell you that our friend in the video does a very good job of explaining it, so take the time to watch him. Now, let's talk about the problem. How hot do you think it is in this room right now? Well, according to this, it's like 26 degrees at least. If I walk over here and take a look, it's definitely not 26 degrees. I got a thermometer. So we've got a bit of a problem. You could also calibrate in the code where it says your baseline temperature. You should always set your baseline temperature right there, right? You got your baseline temperatures. You should always set your baseline temperature for what the room temperature is and then add degrees on as you touch it. Now that's not the problem with this. It is not so hot in here. The cool part is, since I've set this to an A0, an analog in, I can read this sensor in real time. And look, I'm touching this. It is not 40 degrees, but if I go, this is cool, to the monitor function, I can monitor my component that I sent to an analog in. Watch this. I go to monitor, and it clicks this up, and it is telling me it is 79, 76, 65, 63, 63, 63. It's constantly reading thousands of times that it's 60 degrees. So there is an error with how this temperature sensor is reading. The error, from what I have discovered, is in the grounding of this circuit. Obviously, reset. If I unplug this grounding, it just goes right. If I give it back to ground, it instantly, there's some kind of short. The problem is that the grounding here, going to this grounding strip all the way there, is also connected to the grounding of these 3 LEDs, which are coming from these 3 pins. There seems to be a little bit of interference between these digital out pins being grounded on the same strip that an analog is grounded in. I'm using the ground here. So I've got digital things being grounded from my 3 digital outs that change as the temperature is changing here. And I also have an analog sensor being grounded on the same strip. And theoretically, it shouldn't make a problem. A couple solutions you could do is put a resistor there, a 10 kilo ohm resistor instead of a wire. That would probably fix the problem. But the easier solution, I've got the longest wire in the world for some reason. All you need to do to make this work is unplug that. Now, instead of grounding to this strip here, we're going to ground. And notice that see, this is the ground pin. Your Arduino has extra ground ports. There's another ground right there. There's ground 1 and ground 2. We're only using the 5 volt and ground 1. We can use another ground right here. Look what happened instantly. The lights went down, and look at the temperature. 22, 22, 22, 22, 22. Now, this is still a little bit above the baseline temperature, right? Because 22 means that one of these go on into our code. So I could go in and fix my code to make the baseline temperature 22. Or I could just take a freezy, which I'm going to eat after, and cool it off a little bit. Right? And as I touch it, now that I cooled it with a freezy, it's going to take a while to warm up. It will warm up. I'm just not that hot on the level-meter. Come on, baby. Whoa! And then as I take it off, it will slowly start to cool down. So take some pictures of it warming up and some pictures of it cooling down. It'll take some time. Want to cool that off again because it's a little hotter in the room. There we go. So all you need to do is, instead of grounding to this ground strip here, ground it to a new ground there. Run that pin there. So go out of 8 into the ground on the side here because you've got multiple grounds. And that will fix the problem. But isn't this cool how you can read the temperature in real time just by going on the monitor. And when you're troubleshooting sensors in the future, press that monitor button and it's going to tell you if it's getting signals or not. The next project isn't as glitchy, but it's a lot harder to wire. Good luck. Oh, sorry, one more time. That's what you need to be working on. I'll put it in the Google Classroom. Read, build the board, watch the vids, write the code, upload it, fix the error, submit that, submit the code, and submit the board. Thanks.